Hi everyone, we are Team 都可以. My name is Xueqing. Today we are presenting Main AI, a predictive maintenance platform that built for Asian small and medium enterprises. With my teammates Brian and Evan, we built Main AI. We chose case study 1 because it addresses a real urgent problem. Asian SMEs power our economies but operate blind. When a motor fails, production halts for days or weeks. Current maintenance is either reactive or wasteful, and enterprise solutions cost millions. SMEs have no middle ground. Our solution is a three-step system. Managers upload existing sensor data. Our XGBoost model predicts how many days until failure, and the dashboard tells them exactly what to do and why. No new hardware, no IT teams, just a browser.
Hi, I'm Evan. I'm here to talk about the demo. First, we log in into our account. We bring you to a Go homepage. This is a homepage. For the dashboard, you will see previously added equipments like boiler feed pump and line A compressor. So we're gonna add one equipment, for example, packaging motor. It's a motor type. The brand will be Siemens. Using it, we actually used it last week ago. Cycle completed 15. The load capacity we're using it will be 80%. Temperature, let's go with 80 degrees. And vibration. For the CSV, you can load your machine logs where the ML will track and predict the wear and tear of your machine. So currently our packaging motor is like this. The battery is 33% and the time we have left is 108 hours. The last maintenance will be here. So here you can actually see a chart. You see a chart of the details of like temperature, vibration and RPM. And here we have overview, maintenance. You can see the previously maintenance and analytics of your machine revenue, like how much is cost for maintenance and the money of this machine generates. It will help you calculate them all together and give you a chart. For example, if we maintain this packaging motor, currently we can maintain. It's inspection maintenance date is today. Cost will be 1,000. The name of the technician is Amir. Then this is replaced. Where is replaced? Motor. The motor is replaced. You can choose your battery health will go back to 100% or what. So we'll put 100% reset cycle. Those will be here. Then we save maintenance. The battery will go back to 100%, and your maintenance here will show the cost. Analytics will show that he has already used 100 ringgit, 1,000 ringgit. So if we can edit the economics, we can put like the revenue, how much this packaging motor save money or generates the income. It's right, 5,000. Margin, then the cost of this will be 200. Placement cost, we can put 1,000. Okay, save economics. They will show you in the analytics here, will show you the cost, pressure, and down risk and maintenance wise. Moving on to the predict RUL, you can use any logs or CSV file that produced by the machine. For example, with FactoryGuard sample, you can execute the ML model and so it calculates how long this machine have left, how long until the next maintenance is needed. So for example, it's like we only have 164 hours left. So I can choose to add to my fleet, type in the name, factory machine, then we can deploy asset. As a CV added into your machine, so you go back dashboard, you show your factory machine and show the chart. I think that's about it. And over here you have alerts and the maintenance logs of your machine. That's about it. Thank you.
So now we move on to the technology used in Main AI. So we built the entire stack in Python and JavaScript. XGBoost handle RUL regressions. SHAP explains every prediction in plain language, and FastAPI serves the front end with a clean REST API. The whole system runs locally with no cloud dependency, critical for SMEs with limited connectivity. Our business model is a simple monthly SaaS subscription. So let's say a food processing SME with 5 machines pays around 99 ringgit a month. This subscription fee is less than the cost of 1 hour of unplanned downtime. Besides that, we will also provide hands-on training workshops of our system. We keep infrastructure costs low by running XGBoost on the standard VPS, so no GPU required. So up next, let's talk about market segment. Our primary segment is manufacturing SMEs in Malaysia, specifically food processing, where a single cold chain failure can destroy an entire batch of product. The market size of SMEs in ASEAN is around 98.6 million SMEs. Therefore, we'll first start locally in Malaysia and slowly expand to Indonesia and Thailand and Vietnam. So after that, we'll prove the model to be consistent and accurate, and then we'll expand across all over ASEAN with a translated interface that is dedicated to their own country. Now let's talk about competitor analysis of main AI. So existing solution fall into two camps: enterprise platforms, which is our competitor, which costs a fortune, of course, as you can see here, requires sensor hardware; enterprise AI, that is not SME focused, complex setup, and their AI can't even predict anything. That's why we created Mate AI. It is a lightweight SaaS with affordable pricing, no new hardware needed, and SHAP explainability that tells operators why a machine is degrading and not just that it is. Lastly, here is our future improvement and expansion. Our roadmap takes Mate AI into 4 phases. Currently, we are in phase 1. So phase 2 will be integrating IoT sensors that will alert user through WhatsApp or their email. And up next in phase 3, spare parts prediction, maintenance cost optimizer, and a multi-site dashboard will be added in. And in phase 4, we are planning to have a digital twin simulation and API for ERP integrations. So long term, we see Mate AI becoming the go-to predictive maintenance layer for all of Asia's SME manufacturing sectors. This is Team Dokei, and that is all about Mate AI. Thank you.